name is Mrs. Getson and welcome to my science kitchen. Today we're going to talk about something called air pressure. Now the first thing you need to know about air pressure is that it is created because there's molecules in our air. And the molecules in the air are considered a gas. Now gases are very excited molecules and they're moving all over really fast. And when these molecules move together and all over the place, they bump into each other, they bump into things next to them, and they create a pressure. Now, so do solids and so do liquids. They create pressure too. So you don't feel the air pushing up against your body because your arm is pushing back. And the pressure of them pushing against each other equal each other out, cancel each other, and there's no problem. You don't feel it. So we're going to try to prove today that you can change air pressure and create more on the outside of these pop cans than the inside. And we'll see what happens. So the first thing you need for this experiment is 2 pop cans emptied out. You don't want the pop in them. You're going to want a frying pan. You're going to want 2 containers just with cold water in them. And I have tongs because I want to be safe when I pick these cans up because they're going to be hot. And if you don't already have glasses, you might want a pair of safety glasses because we are going to be dealing with a little bit of steam. Now, you may notice I already have the flame underneath the pan. That's because I have added about 1/6, just a very little amount. Now, the amount you add isn't that important, but the smaller amount of water that you put into these cans, it won't take as long to heat up and start steaming. So, I guess if you're willing to wait, you can put more water in it. Then you're going to need about 1/4 cup water in these 2 containers. Now, I put ice cubes in them because I want them to make sure that it's really cold water. I want a big difference between the water in these containers and the water that's going to be in the pop cans. Now, in just a minute, I'm going to see visible steam coming out of these pop cans. Let's go ahead and can you zoom in a little bit and let's see if we can see the steam? Okay, I see steam. This green one here definitely has steam coming out of it. And, hang on, so does the pink one. So I'm going to first take my pink can and I'm going to put it in my first container. Not much is happening. Let me look. I don't see steam coming out anymore, so that's definitely one change. But other than that, it looks exactly the same. That's because as the steam cooled down, condensed and went back into a water form, the air filled up the inside of the can. And the air inside put pressure on the inside of the can along with the air pressure on the outside, so it canceled each other out. The can is able to hold its shape. Now, I'm going to take this green can, and what I'm going to do is I'm going to turn it upside down. That's going to form a seal so that no air can get back inside the pop can. And voila! Look at that. What happened? And why did it happen? When I turned it upside down, that can collapsed because there was no air inside that can, and the air pressure on the outside of the can, well, it was stronger. So it actually crushed the inside of the can. That's air pressure. It's all around us. I hope you enjoyed this experiment, and come join me in some of my classes at Excelsior. We do these kind of experiments all the time, and they're a lot of fun. So I hope to see you soon. Bye.